Hello, class 9th physics, chapter motion. So in this chapter we are going to study motion in a straight line and motion in a plane. We are not going to study some other kind of motions like periodic motion or any other kind of three-dimensional or zigzag kind of motion. We are not going to study that, but we are going to study only motion in a straight line and motion in a plane. But first, let's discuss about what is motion or state of motion. But before that, we have to discuss about state of rest. Then we can discuss about state of motion. If I ask you that can you think about a situation in which a body is in the state of rest as well as in the state of motion? This question sounds weird and illogical also, but yeah, it is a completely logical question. If you think about it, you can pause the video and think over it. Okay, let me put a situation in front of you. Let us suppose you are traveling in a train and you are sitting on one of the seat and uh, your friend is sitting next to you. So both are sitting and there is no movement uh, of any one of you. Then with respect to you and the compartment, your friend is in the state of rest with respect to you or with respect to that compartment. But if there is another person who is outside the train and train is running, then for that person both of you are in the state of motion. So it is just a matter of frame of reference or a reference point from which the motion is observed. So whenever we discuss about motion, it is always relative to a reference point. It is always observed through with respect to a reference point. So before a state of rest, before a state of motion, we have to discuss about reference point. So a reference point is the point or is the position with respect to which movement or motion uh, or any physical changes in the position is observed. In short, we can say reference point is the point with respect to which the motion is observed. Okay, now what is the state of rest? State of rest is always with respect to a reference point, and the state of motion is also with respect to a reference point. So we can say that the state of rest, a body is said to be in the state of rest if it is not changing its position with respect to a reference point. And for a state of motion, a body is said to be in the state of motion if it is changing its position with respect to a reference point. So Now what we can do, so from here we can conclude there is nothing like uh, absolute rest or absolute motion. We can't guarantee anything that it is always in the state of rest in all conditions, or it is in the state of rest at all conditions. It is always relative. Like the earth is moving, and see, earth is performing a very complicated motion. Earth is spinning about its axis. It is also orbiting around the sun, and it is precessing like a top. It is precessing like a top very slowly. So later on, it will. It is also going like this, but very slowly. In fact, entire our solar system, if this is the sun and these are the planet, entire our solar system is also moving. And through the galaxy, if this is our Milky Way galaxy and we are somewhere here, it is also going this way. So it's a set of complicated motion, but on the surface of Earth, we consider the Earth and all the objects which are not changing their position um, with respect to Earth, we consider them in the state of rest. So it is a very subjective topic. Uh, it depends upon the choice of reference point, and we consider that choice of that reference point, we consider that choice in the state of rest. We consider Earth in the state of rest while studying motion around it. So that was just the discussion over the state of rest and state of motion. Okay, moving on. Now, what are we going to do in this chapter? So, uh, basically, what our primary target is, we want to uh, study about different type of linear motion, motion in a straight line, as well as motion in a plane. And can we predict the position of um an object moving with certain speed or certain ways by which it is moving? Can we predict where it will be after some time? Or can we predict that how much time will it take to cover so and so distance? So all of this we are going to do in this chapter. So let's start. First of all, we have to just talk about some of the parameters. So there is first parameter to study motion is distance, and there is another one which is displacement. Distance is quite obvious. We have from our childhood till now, still you are children, but okay. So since your childhood, you are familiar with this term distance, though you don't know its definition, but actually you are aware about distance. But displacement, it is a bit tricky term, and not commonly not in our common use. That is why it becomes bit complicated one, because it is not in our use. Actually it is in our use, but we don't use it in our daily life, in our common discussions. But distance, we use this term uh, quite often. So what is this distance? Actually, it is the length of the path traveled by a body. Moving body. This is distance, length of the path. Finally, you have to measure the length of a path, and that will be the distance. So, let us suppose there is a path like this, straight road, or a sprint track, cricket pitch, whatever. Or let us suppose another road or some other track, whatever. There can be many type of path. This one, and so on and so forth. In our daily life, we have seen so many paths. But distance is not the length of this path, but length of the path traveled by a body. If a body travels, starts from here and reaches here, then this much length, measurement of this much length is the distance traveled. If object moves from here to this point and then come back somewhere here, then we are not going to measure just from here to here, but we will measure this length as well as this length, and entire this length will be called distance. So also here, if object goes like this, so entire this length will be called distance. And how are we going to find distance? Few students might say that distance equal to speed into time. Yeah, true. But in order to find distance, we don't need this formula. We need a measuring tape. We can use a measuring tape. We can measure this length. That's so simple. That's so easy, super easy. So then people might say, then what to do with this formula? Yeah, it will also be used if we don't have measuring tape, but we have the information of speed as well as time. Then only. If nothing is given, how can we find distance? So remember that. So here is the discussion about distance. Now what is this displacement is all about? So let us suppose uh, there is a race, and there's not a proper track for that, but there is a starting point somewhere here. Any racer can start from here, and they have to reach somewhere here. There are tall buildings in the place, there are trees, jungles, there's a mountain, and at the mountain top there is this point. And no matter which path you choose, you have to reach this point. Now there is a target only. So we are interested in this initial position and this final position. We are not interested in the path followed. Whichever be the path you want to go like this, okay, you can. You want to go like this, you want to fly, whatever be the path, we are interested in the initial point and the final point. So we are we want to approach this point. So ultimately, whatever be the path we have chosen, ultimately, if we join initial and final position with a straight line, then length of this separation will be called displacement. That's it. All right, so displacement is, I have to remove it all. Yeah, this one also. Um, Displacement. In the books, it is written like a shortest path between 2 points, initial point and final point. But that gives you a confusion that you people might think that, okay, shortcut is called displacement. No, actually it is not. So what I suggest, so I suggest straight line separation, the measurement of straight line separation between initial and final position. People might say that why not straight line distance? I don't want to use the term, the word distance, because we have already used it here. So student might get confused. So for displacement, I I, um, I suggest students to write the straight line separation between initial, means starting, and final position of a moving object. So that is displacement. Okay, uh, there comes a confusion, a basic confusion. Throughout my experience, I've observed more than 90% student have this confusion. So first, just remove that confusion, which I'm going to explain you what is the confusion. So let us suppose there is a point A and there is a point B. And if there's an ant which is crawling from A to B. If the ant is crawling in this way, what will we call this? Distance, displacement, or nothing? Next, just keep your answer in your mind. Next, let us suppose the ant crawled along this line. What will we call it? Distance, displacement, or nothing? Well, we will call, in both the cases, we will call it nothing. You might be surprised, but yeah, of course. What I asked you, first I asked you that if an ant crawled like this, what will we call it? Distance, displacement, or nothing? So it's nothing. Just the motion, we can say. Here, again, motion. But I hope, I believe, because it's my observation, that most of you have called this thing as distance and this thing as displacement. So where is the fault? Where is the error? Where are you wrong? Now I rephrase my words. If we measure this path, what will be the length of this path called? Okay, what will be the length of this path called? And then your answer will be distance. What will be, oh God, what will be the length of this, this path called? So that will be called distance. Okay, now I'm changing my statement. Again, same question. For this red line, what will be the length of, I will write it again, what will be the length of this path called? So most of you will give the answer displacement. But no, I am interested in length of the path. So it will be called, it will be distance again. Length of the path is distance. Simply, the measurement of length of the path is distance. No matter whether it is straight, whether it is curved, whether it is zigzag, whether it is of any other form. Ultimately, if we are interested to find length of the path, then it is distance and nothing else. That's all. End of the story. So where is distance? Which type of question will we ask for distance? Displacement, sorry. Displacement. So displacement, for displacement, the statement will be like, what will be the straight line separation or shortest distance, because they often give such type of statement in these cases. In both the cases, see, in both the cases, can we find length of the path? Yes. In both the cases, can we find straight line separation between these 2 points? Yes. So the concept of distance and displacement is irrespective of the path followed. I repeat, the concept of distance and the displacement is irrespective of path followed. It depends upon which thing are we measuring. So if we are measuring length of the path, then it is distance, and if we are measuring the straight line separation or the shortest distance between 2 points, then it is displacement. Now, in the same question, both distance and displacement can be asked. Let me give you some examples. Okay, so one thing before that, one thing I want to make it sure that for this case, if object is moving in a straight line, for such cases, length of the path, that is distance, and the separation between 2 points, that is displacement, both are equal. But still there is a condition. See, Physics is all about some conditions and some complication. Yeah, of course. We can't say that distance is equal to displacement, because displacement can be negative also. So even if an object has traveled in a straight line, still it is subjective to a positive or negative sign, whereas distance is irrespective, is always positive. It has nothing to do with signs. So I will explain it later on. But first, let us solve some of the uh, problems based on distance and displacement. So as I told you, for a same problem, we can find distance as well as displacement. Case 1. There is a point A. So a boy started running and reaches point B. This is the starting point and this is ending point. And from here to here, if we measure length of this path, it is 50 meter. So what is the distance here? Distance equal to length of the path. Obviously 50 meter. And what is the displacement? The straight line separation between initial and final position, which is 50 meter. Remember one more thing. This displacement is the matter of positive or negative sign. This is incomplete information. For class 9th, well, we ignore that part, but we should think over it. Displacement is sign sensitive. Because displacement takes place in a particular direction. This is a starting point, this is ending point. We can't say both things are same. It has started from here and it ends here. So it has traveled a definite distance in a particular direction. If this is east direction, we have to write eastward. We can't write it westward. So right now, because with respect to this plane, it is toward right, so I will call it toward right. So here what I told you, that although they are same, but still we can't say that both are same, because for distance it is 50 meter, end of the story, nothing else. But for displacement it is 50 meter, but in which direction? So toward right, as far as this particular situation is concerned. And if I choose right direction as positive, then I should write it plus 50. I don't require to put positive sign, but I'm purposely writing it, because if I'm going to take a measurement in leftward direction, then I have to take it with negative sign. Another case, this time a girl, so that there will be a gender equality. A girl starts from point A, reaches point B, again this length is 50 meter, then she returns back and reaches on other side 25 meter. This point C. Now, if I ask you what is the distance, so it is quite obvious. Distance, again, length of the path followed by an object, by a body, by a person. So girl first traveled this path, then this path, and then this path, means 50 plus 50 plus 25. So it is 125 meter. And okay, there is a condition. Actually, we can choose any direction positive, any direction negative, but let us suppose in the question they have given right direction as positive and left direction as negative. So if we want to find displacement, so displacement is actually the straight line separation between initial, means starting point, this point, and final, means ending point, this. It is 25, and it is toward left. We have, no one have assigned us, we have assigned right direction as positive, left direction as negative. This is our reference point, so that will be positive, this will be negative. It ends here at point C, it starts from here. We are not interested in the path followed if we are concerned with in order to find displacement. So this is the displacement. It is 25, yes, of course, toward left. Or we can write minus 25 meter. Remember that. So displacement is sign sensitive. It can be positive, it can be negative. Moving on. Another question. This time, let us suppose an object moving like this. This is the starting point A, then it reaches B, and then ends at C. I can give you Pythagorean triad here, but I will give some complicated terms like 10 meter and 5 meter. Yeah. So we have to find distance as well as displacement. So once again, I will repeat again and again this thing that distance and displacement are not subjected to which way object is moving. Is it moving in a straight line or in a plane? No, it is subjected to the measurement. So what are we measuring? Are we measuring length of the path, or are we measuring just the separation between initial and final position? Length of the path means distance, separation means displacement. Keep this thing in your mind. So distance, this plus this, AB plus BC, 10 plus 5, that is 15 meter. And displacement, the separation between initial and final position, that is AC. Now see, now maths will be involved in such type of question. It doesn't mean that displacement will always be obtained through this way, but because this question demands the length of AC, which is hypotenuse, and we know by Pythagoras theorem that we can do this. Can we find its root? Yes, we can. So it is an assignment for you. Try to find it out. Or in our school life, we can do it like this only. I'm not explaining how is it so. Find it out of your own. Okay. Next, another question. Let us suppose there is an object starts from A, then it follows a semicircle of radius 50 centimeter. All right, so the question is, it has traveled along this path, semicircular path, and ends up here. So distance in this case will be, you can pause the video, you can give a try. So distance is the length of the path. Again and again I will keep on repeating this throughout this video, and maybe in the upcoming videos also. Distance is length of the path, that is this arc length. So we know if it would be a circle, that the entire length would be circumference, so it is the half of the circumference, so it is 2 pi r divided by 2, so it is simply pi r, so it is pi multiplied by 50, we can write 50 pi centimeter. You can leave your answer as it is, it's a tricky part. If it would be an MCQ, then further maybe they will give this option, or if they are cruel enough, so then 50 multiplied by 3.14. I hope you people are good at calculation. If you are not, then you have to be. So here in this question the answer is 157. That's it. Yeah, that's it. Okay, but what about displacement? Oh God. Again, displacement is a straight line separation between initial and final position. We know only this is 50, we don't know what is it, but it is radius also, this is radius, this is diameter in fact, so that is diameter, and which is 2r, and which is 2 multiplied by 50, which is 100 centimeter. Want to convert it into meter? This one also you can do it. That's your part. Okay. So far we have done some nice questions. Now, not so nice. I'll give you another question which is not that nice. Of course. An object starts from point A and reaches point B okay, in a circular path, and radius this time 10 centimeter. That's good, that's enough. So you have to find again distance and displacement. Now once again, what is distance? It's the length of the path. So this one, quarter of the circumference, 1 by 4 multiplied 2 pi r, that is pi r by 2, that is pi multiplied by 10 by 2, that is 5 pi. I am leaving it as it is, centimeter. And displacement, this time it's not that simple like in previous case. In previous case it was just the diameter. This time it is not such a simple case. This is bit tricky. This is the displacement. It is a quadrant. So again Pythagoras theorem will be applied. So AB is equal to root of 10 square. This one will also be 10 square. You people might do it in a different way, but my method is bit different. Okay, another question similar to this. A square is there, and this time object starts from A. So let us suppose, okay, each side is 20 root 2 centimeter. So if particle starts from A and completes 3.5 rounds. Rounds, yeah, rounds. This is only the term which is used when one one cycle gets completed. Okay, then find distance and displacement. This time question is little bit tricky, not that much difficult, but little bit tricky. So distance, it is 3.5 rounds. So in each round it will cover the distance equal to its perimeter. What we can do, we can directly multiply 3.5 with its perimeter. And what is its perimeter? 4 multiplied by side. So it will be 7 by 2 multiplied by 4 into side is 20 root 2. I am leaving it as it is. You can further simplify it. You can leave answer with root 2, or you can put the value of root 2 also. Displacement, if it completes 3 round, 1, 2, 3, still it is at A, but then it takes half round, it is now at C. So this is 20 root 2, this is 20 root 2. What will be the value of AC? This is AC. AC is equal to root of this square, 20 root 2 square plus 20 root 2 square. And as I told you, it will be 20 root 2 root. See, remember, when there are two terms, similar terms inside the bracket with plus sign in between them, then just take one of them outside the root and leave root 2 inside. Root 2 multiplied by root 2 will be 240 centimeter. Yeah. Now, a most complicated question with a simple solution. Maybe if I could easily make it, yeah, here it is. So, okay, each side measures 1 meter. 1 meter each, and we have to find, okay, it starts from A and ends at A. We have to find distance as well as displacement. Similarly, another question. There is a circular path, object starts from A and ends at A. Its radius is 7 centimeter, 7 centimeter, 7 meter. That will be convincing one. And there is a square. It starts from A, ends at A. Its each side is A, let us suppose. And finally, there is point A and B. Distance between A and B is 50 meter. Why 50 all the time? 450 meter. It starts at A, ends at A. Now, in such cases, if you have to find displacement, so remember, from A it is starting and at the same point it is ending. Displacement is the separation between initial and final position. There is no separation. Initial and final position are the same. Displacement is 0, displacement is 0, displacement is 0, displacement is 0. But distance not. Particle has traveled some distance. Distance can also be 0, but if particle didn't move here, displacement is 0. I am leaving distance part up to you. You can solve it. So now I hope the difference between distance and displacement is clear to you, and in future there would be no more confusion. So, let me give you an example. Let us suppose this leaf. Okay. It has started from here and reached this point. From here it has traveled till here, like this. So what is it? What is it? If your answer is again distance, then you are wrong. It is just the motion. There's nothing we can say about it. The question is incomplete. What is it? What is it? The leaf, the curved line, the motion. But if I ask you that what is the measure of this length, then your answer will be the distance. And if I ask you what is the measure of this separation, then your answer should be displacement. Keep this thing in your mind. So again and again I will keep on reminding you, distance and displacement depends upon the measurement we are interested in. They are irrespective of the way the object moved. Okay, further before concluding this, let me tell you that distance is always greater than or equal to displacement. One more thing, I have to put mod. This is called mod, modulus. That gives numeric value always. Because displacement can be positive, negative, or even zero for a moving object. Distance can be positive only, but displacement can be positive, negative, zero, even zero for a moving object. Otherwise distance can also be zero if object is not moving. But if object is moving, for moving cases, for motion, for object in the state of motion, I have just written it in a meaningless short form. So, but you can understand it. So displacement can be positive, negative, even zero. So that is why I have put mod that, okay, I am taking even positive value of displacement, but despite of that distance will always be greater than or sometime equal to. I am not explaining in which cases it is equal, but sometime equal to displacement. Sometime this form you need to memorize. If we take ratio of both of them, that will be greater than or equal to 1. Quite simple mathematical thing. If we take it here, there's multiple 1 will remain there. So it will be like this. Distance upon displacement is greater than or equal to 1. So keep this thing in your mind. There are similarity also. Distance has unit, meter, SI unit actually. Otherwise there is centimeter, there is kilometer, there are big units like light years, light traveled, light years, okay, it sounds like time, but it is distance. Light year means distance traveled in 1 year by light in vacuum. So distance SI unit is meter, displacement SI unit also meter. So that's all in this video. See you in the next video.